We believe there are about 100 billion galaxies in the observable universe. This is clear evidence that the entire world and creation do not surround Earth. This discovery has shattered the idea that the Milky Way is the only galaxy in existence and has shown us that we are only a small part of the universe. We have gathered knowledge about Andromeda over the past centuries, but most of it has come from observations made on Earth. But with cutting-edge instruments like the James Webb Space Telescope, our view has changed dramatically. Amazingly, the latest data from the James Webb Space Telescope has challenged our previous understanding of the Andromeda Galaxy. Another cosmic mystery remains unsolved. JWST has received a signal from a nearby galaxy that has astonished the entire scientific community. Learn how JWST received a warning signal from our closest friend, the Andromeda Galaxy. Of course, the appearance of the Milky Way has changed dramatically throughout human history as a result of our understanding of the universe. In ancient times, when our technological capabilities were limited, the Milky Way appeared as a faint streak of light in the night sky, giving rise to various explanations and myths. It is often considered an important and central theme in the world's beliefs of various cultures. Especially as our scientific knowledge advanced with the development of the telescope and the work of astronomers such as Galileo Galilei, we realized that the Milky Way is not just a celestial body, but a large collection of stars, planets, etc. This understanding of celestial bodies changed our understanding of our place in the universe. Today, thanks to new telescopes and astronomical research, the Milky Way is seen much more clearly as a bridge of spiral galaxies containing billions of stars, including our Sun. It was discovered in the 1920s by American astronomer Edwin Hubble using the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble observed distant nebulae beyond the Milky Way. His observations and analysis of these objects showed that they were not part of the Milky Way, but were all separate entities, each containing billions of stars. One of the nearby galaxies is the Andromeda Galaxy, also known as M31. The Andromeda Galaxy has a rich history of observations spanning centuries. One of the most famous records of this celestial body dates back to the 1000th century, when the Iranian astrologer Abd al-Rahman al-Sufi noted a small cloud on his star map of the time. The significance of this observation lies in the fact that Sufi was able to identify this distant world solely by relying on his own vision and direct observation, without the aid of telescopic equipment. As early as 1612, Simon Marius provided a description of the Andromeda Galaxy based on telescopic observations. His work laid the foundation for future astronomers studying this vast cosmic structure. Later, in 1764, the famous French astronomer Charles Messier listed the Andromeda Galaxy as M31 in his famous Messier catalogue, incorrectly attributing the discovery to Simon Marius. However, this does not diminish Messier's role in putting Andromeda on the map. Nearly 100 years after this discovery, astronomers around the world are seeking a better understanding of this mysterious galaxy, contributing to the latest galaxy discoveries. Before that, in the early 1700s, Italian astronomer Galileo Galilei revolutionized our understanding of the Milky Way. Using newly developed telescopes, he made groundbreaking observations that challenged our worldview. In 1750, British astronomer Thomas Wright proposed a new hypothesis in his book The Principal Theory of the Universe, or a new hypothesis. According to Wright's hypothesis, the Milky Way is not a random distribution of stars in space, but rather a very flat layer of stars. He also said that part of this huge structure was our solar system. Wright's hypothesis was a step forward in understanding the formation of the Milky Way, but it was limited by the observational technology of the time. A huge leap forward in the form of the Andromeda Galaxy occurred in 1864, when the British astronomer William Huggins made a groundbreaking observation. He studied the spectrum of Andromeda and discovered that it was different from the spectrum of a gas nebula. This observation opened the way for the world to understand Andromeda for what it really is. The Andromeda Galaxy is a large planetary structure located close to us, and its mass is estimated to be between 1 and 2 trillion times that of our Sun. With every exploration, the discovery of galaxies like Andromeda continues to expand our understanding of the universe and our place in it. Until recently, scientists believed that Andromeda was 10 billion years old, which is very old by cosmic standards. One of the most interesting aspects of Andromeda's origins is that it is believed to have formed from the merger of several smaller protogalaxies. This suggests that over billions of years, the smaller galaxy structure would have been compressed to form the beautiful Andromeda Galaxy we see today. Galaxy mergers are common cosmic events that shape the growth and formation of galaxies. However, for a long time, astronomers believed that Andromeda was much larger than our own Milky Way. This misconception is understandable, as diagnostic tools were scarce in the 18th and 19th centuries. Recent studies have reconsidered this belief. The new results have allowed scientists to somewhat lower their estimates of Andromeda's mass, while increasing the mass attributed to the Milky Way. The current understanding is that the masses of these two world giants are much closer than previously thought. So if you were sitting in Andromeda and looking at Earth, you would see a similarly massive galaxy. This gives us the size of the Milky Way. However, the physical size of the Andromeda Galaxy is something that astronomers completely agree on. It is known to be 220,000 light-years in diameter, extending far beyond our own Milky Way. The Andromeda Galaxy is about 100,000 to 175,000 light-years larger in diameter than the Milky Way, making it a very large planetary body covering a large area. These new observations highlight the complexity and challenge of accurately measuring the mass of galaxies. At the center of the Andromeda Galaxy, a supermassive black hole pulls the stars around it strongly. These stars orbit the black hole in an elliptical path, similar to the planets that orbit the Sun in our solar system. When a star approaches the black hole at a certain point in its elliptical orbit, that point is called perigee. At perihelion, the tidal forces are strongest and the star moves at its fastest speed. This happens when the stars gather and become more concentrated in the space around the black hole. When the stars collide, energy is released in the form of radiation, including visible light and other forms of electromagnetic radiation. The increased density and radiation from stars creates the brightness that astronomers see in the Andromeda Galaxy's powerful nuclear pocket. This phenomenon provides important clues about the dynamics and interactions between supermassive black holes and the stars around them. To understand this better, let's look at AGNs. Active galactic nuclei, also known as AGNs, are high-energy regions at the center of galaxies. They are characterized by their ability to emit light at wavelengths ranging from radio waves to X-rays. AGNs are driven by the presence of supermassive black holes in the galaxy's atmosphere. These supermassive black holes are extremely dense regions of space that contain so much mass that they can fit into a very small volume. Astronomers find some very interesting phenomena when they observe active galactic nuclei using modern telescopes like the Hubble Space Telescope. One of the most interesting features of the Andromeda Galaxy is its active galactic nucleus, AGN. It appears to have two foci, or separate regions that emit more light and different types of radiation than the surrounding regions. The brighter focus is the second focus, located further away from the true center of the galaxy. This region contains a supermassive black hole, which is estimated to have a mass of 1.1 to 2.3 times that of the Sun, or 110 million to 230 million times that of the Sun's. Supermassive black holes exist at the centers of galaxies, including the Milky Way, and are thought to play a major role in the evolution and dynamics of galaxies. When matter such as gas or stars get too close to a supermassive black hole, an accretion disk forms around it.